Hey math fans, welcome to section 4.1.2. Let's get started. In this section, we're going to be describing distributions. We're going to be looking at the shape, the outliers, the center, and the spread, also known as the SOCs. For the shape, we're going to be asking ourselves, is the distribution symmetrical or is it skewed to one side? Is it unimodal or perhaps bimodal? Also, we'll be calculating outliers later, but we can observe some potential outliers. For center, we're going to be choosing either the mean or the median. We can look at the mode, but most of the time we will be looking at the mean and the median. And finally, for spread, we could look at such things as the range or the interquartile range. We won't be using standard deviation. We'll be using something called the mean absolute deviation. First thing we're going to look at is symmetric. The dot plot you see before you is a symmetric distribution. Notice how the left side and the right side are both pretty much balanced. The next question we should ask ourselves is, which measure of center should you use? Should you use the mean or the median? If this was skewed, I would definitely be using the median, but since it's symmetric, I will more likely use the mean, but it doesn't matter which one for symmetric. Both of these are okay to use. This distribution is skewed to the right. Skewing to the right or the left is often confusing because it's the direction of the tail, which is the direction of the skewness. Notice the tail of this distribution goes towards the right. Sometimes I think about a skier and which way they would ski down a slope such that they don't kill themselves. For skewed data, we should always be using the median because the mean will often be skewed in the direction of the tail. And this distribution is skewed to the left. Again, which measure of center should you use? You should use the median. This particular data set has 18 values, so that means that the 9th and the 10th value will get averaged. So as you can see, the median will be here. However, the mean, because of these lower values, will more likely be to the left, and it will not be a typical value in your data set. To describe spread, we are going to be looking at the mean absolute deviation. Well, what does that mean? Well, the mean is the average of all the data values. Absolute value, you guys know, is the distance from zero. And then the word deviation means distance from the mean. In other words, we're looking for a typical distance from the mean. Later on in AP Statistics, we will be using standard deviation instead. So in example 1, we have two hockey teams, and we're recording the number of goals scored. Team number 1 is the Ice Kings. Team number 2 is the Gliders. We're going to be describing the distribution using SOCs: shape, outliers, center, and spread. For the spread, we're going to be doing the absolute deviation, the mean absolute deviation. As always, put the data in order. Next, do a graphical display of data for each of the two teams. Team number 1, the Ice Kings, the data looks pretty symmetric. Same with team 2. Since both teams have relatively symmetric data, we can use the mean, and then it would make sense for us to use the mean absolute deviation. The symbol for mean is this symbol right here. We call it X bar. It stands for the average or the arithmetic mean. The mean number of goals scored for the Ice Kings was 2.14. The mean number of goals scored for the Gliders was 2.36. Next, let's calculate the measure of spread. And since we will be using the mean absolute deviation, the best thing to do is to create a table. Again, the mean absolute deviation is we are asking ourselves, what is a typical distance from the mean of 2.14? This is how you do it. You take the value here, which is 0, and you're going to subtract the mean, which is 2.14. Then you're going to take the absolute value, which is just going to be positive 2.14. You do this with every single value. Next, you want to add up all the differences. And finally, you want to divide by the number of data points in your set. And we had 14 different games that we had here, until you get to your final answer, which is 1.37. So the mean absolute deviation is 1.37, but what does that actually mean? That means on average, each of these goals scored on average was about 1.37 goals away from the mean of 2.14. Sometimes we were way higher than the 1.37. Sometimes we were lower, but it averages out. A typical distance from the mean is 1.37. Next, we're going to do exactly the same thing, but with the gliders. The mean for the gliders is 2.36. So we're going to take each of the values, subtract 2.36, and then take its absolute value. Again, we're going to add the sum of the absolute differences and then divide by, again, 14 games. The mean absolute deviation for the gliders is 1.55. A typical distance from the mean is 1.55 goals. Some of them are lower, some of them are higher, but a typical distance from the mean is 1.55 goals. Finally, we're going to summarize our findings with the mean and the mean absolute deviation. So you could say something like this. The two teams have performed similarly over the 14 games. In any given game, you could expect either team to score at least 2 goals. The Ice Kings have a slightly lower mean, but the number of goals scored per game also varies less than the gliders. So notice, the lower the mean absolute deviation, the lower the variation or the variability. The gliders have a higher mean but have higher deviation. So they were either scoring really high or really low. They had a higher mean absolute deviation. This one is more spread out. And that's going to do it for this section. We'll see you in class.